Good morning. Today we are finishing up our CO75. So yesterday we were doing the experiments with flipping our coins and rolling the dice. Today we're putting it together as our class. So we are looking at what we got as a whole class versus what we got as individual students. So let's look at that flipping a coin. You're going to help me fill out what we had. Why is this not working? Help me fill in what we had yesterday with our numbers. So we should get heads 5 times out of 10 flips. And we had 18 students present yesterday, so we're doing our count out of 18. You flip a coin 10 times, how many total flips would that be? It was 180. So we should have flipped heads 90 times. So you did your own heads and tails flips and recorded it. Now we need to determine what happened with the class. How many heads and how many tails. So I'm going to go around each table and I'm going to call on you. How many do we have present today? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, go on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I know Callie was gone yesterday. Who else was gone from math class?
Liam was gone.
Hannah Mae was gone. Okay, so we're going to do a quick change up of our numbers from yesterday because you did the experiment at home. Did you have stuff written in? So Callie and Hannah Mae both watched the lesson yesterday and did the work, so we want to include them in our count. So we're going to change our numbers up here so we can include Callie and Hannah Mae. Okay, so it's going to be 20 kids did our work. So that's 200 flips, and 100 of them should be heads. So when I say your name, I'm going to move this up so people will be able to see the table as I fill it in. You had to flip 10 times.
I know, but now how many times should we have to
100. Because it was out of 200 flips. 20 students, 200 flips, 100 heads. So when I say your name, tell me how many heads, how many tails, and we're going to fill in this table. So as I fill in, you fill in. So every person's going to get their section. We're going to put numbers on. Claire M. Heads. How many tails?
6.
Bryn.
6 heads and 4 tails.
Madison.
7 heads, 2 tails. Wait, what? 1, 5, 6, 7. Oh, 7 heads, 3 tails.
Callie. 2 heads, then tails.
3 heads, 7 tails.
Melanie. So again, as I'm writing, you're writing.
2 heads, 8 tails.
Connor.
5 heads, 5 tails.
Nice, you met that theoretical probability. Madeline.
6 heads, 4 tails.
Layla.
4 heads.
Jimena.
5 heads, 5 tails.
Dom.
4 heads, 6 tails.
Sawyer.
5 heads, 5 tails.
Marina.
3 heads and 7 tails.
Lauren.
4 heads, 6 tails.
Cam.
5 heads, 5 tails.
Ava.
6 heads, 4 tails.
Ruby.
5 heads, 5 tails.
Zelda.
2 heads, 8 tails.
Lilia.
5 heads, 5 tails.
Hannah Mae.
7 heads, 3 tails.
Liv.
3 heads, 7 tails.
Alright, so now we have to figure out how many heads did the class flip. So we need to add up all these heads. So you need a calculator. So we have 4 plus 6 plus 7 plus 3 plus 2 plus 5 plus 6 plus 4 plus 5 plus 4 plus 5, oops, 5 plus 3 plus 4 plus 5 plus 6 plus 5 plus 2 plus 5 plus 7 plus 3. I got 91. Sometimes we miss a number when we put it in. Who else got 91? Okay, so there's quite a few of us that got 91. Let's count our tails. 6 plus 4 plus 3 plus 7 plus 8 plus 5 plus 4 plus 6 plus 5 plus 6 plus 5 plus 7 plus 6 plus 5 plus 4 plus 5 plus 8 plus 5 plus 3 plus 7. And I get 109, which equals out 91 plus 109 is our 200 flips. So, oh, we forgot up on top. We did our heads flip individually and our tails flip individually. You needed to determine the probability of you flipping a coin 10 times matching the theoretical probability. So remember, theoretically, it was 1 out of 2, 50% chance. So if you were my friend that maybe had 6 heads and 4 tails, 6 out of 4 is what probability? What percentage would that be?
60%.
It would actually, sorry, it would have been 6 out of 10. I forgot to put the total flips on the bottom. So that would be 60%. If you were somebody that had 7 out of 3, that would have been 7 divided by 10, 7 out of 3. That would have been 70%. So remember to put the total number of flips, that 10 on the bottom, put how many heads you got on the top, figure out what your personal probability turned out to be. For your experimental probability, how many heads you got over 10 flips. What is your probability that you got? Those of us that got 5 out of 5 had 5 heads out of 10 flips, had that 50%. So this is what our theoretical probability was. Some people actually met that with their experimental probability. Ooh, we had a lot not meet that, right? Theoretically, it was 5 flips. We had people getting 2 out of 10. They were only at 20%. We had people getting more than that. So figure out what your personal probability was. Has everybody done that? You put your heads on top, your 10 flips on bottom, divide it, and write what your percentage was. Okay, so now we're going to look at our class. We had 91 heads out of how many flips? 200 flips. Remember, we changed it to our 200 flips. So what is that probability?
Rounded up.
So we've got 46%. 46% is really close to 50%. If you had gotten 60%, which is closer to 50%, 46 or 60? Which one is closer to 50%? If we have 46%, we had that theoretical probability of 50%, and then a lot of us got 60%. Well, some of us, I see 3. Which one is closer to 50%? 46. It's only 4 away. 60% was 10 away. So if we had done the 4 out of 10, that would have been 40%. So unless you actually flipped 5 out of 5, which only happened 1, 2, 3, 4, 5 times, most of us did not have that 5 out of 5. There's a handful of us that did, but the majority did not. So if you did not get that 5 out of 5, what's closer to the theoretical probability? Your flips or the class flips? Which one was closer to that theoretical probability of 50%? The class flips. When we added everybody's together, that's something to keep in mind as we go to our dice rolls. Zelda.
I was having a roll the heads and I got 87 instead of 91.
Yep, there was enough of us that got the same 91 that I got, so we're using that. Because I think you might have missed a number.
Nope, I got it wrong.
Well, Zelda, I don't know what to tell you. There was almost half the class raised their hand that they got the same 91 as me. So we're just going to go with that and move on, okay? Because the heads that we counted matched up with the heads that we had counted. So we're going with it. Now let's look at our flips. Or sorry, our rolls. So we're going to change our numbers a little bit to include Hannah Mae and Callie. So how many times, if you roll the dice 100 times, how many times should each number be rolled? That stays the same. It was 20 for each number, correct? Theoretically. Then how many students are in your math class? Today we had 2 more. We have 20. So these are the numbers we're going to change. If we roll 120 times 20, we're going to have 2,400 rolls. And then theoretically, each number should be rolled 400 times. That's close to what we put yesterday, right? Yeah. So it's just increased by our 2 people. So we're changing those 2 numbers, these 3 numbers, 20 people in class. So that's 2,400 rolls and 400 for each number. So we're going to use those numbers as we go on. So make sure you updated those numbers because we will need that. So first thing we're going to do is make sure that you calculated the probability of you rolling a die 120 times for 1s, 2s, 3s, 4s, 5s, and 6s. So you need to find your probability for each of those numbers. So you rolled 120 times. How many times did you roll a 1? What's the probability of rolling that 1? So if you had 19 ones, what are we going to divide the 19 by? What are we dividing the 19 by? No. How many rolls were there altogether for you? So I need a lot of writing happening, and I have a lot of people playing right now with their fidgets. Put all the fidgets away, put a pencil in your hand, and be writing. So I should see your probability for each of these numbers. How many times you rolled it divided by 120, what is the percentage? For 1, for 2, for 3, 4, 5, and 6, what is your percentage? So each one of those, you should have already added them up. Now you're dividing each one by 120. So take your number, divide it by 120, and write your percentage down here. So what's your percent? What's your percent? Your percent? Your percent? Your 5s divided by 120, what's that percent? Your 6 divided by 120, what's that percent? So I should see 6 percentages written down. So do you have your 6 percentages, Sawyer? Okay, so that's what you were asked to do right now. So every person is taking how many ones you rolled, divide by 120, write the percentage underneath it. So I asked you to put that away. So how many ones did you roll?
13.
So 13 divided by 120. You should have a decimal, right? So turn that into your percentage and write that down.
And then
Nope. So we're doing that first. Yes.
we get like 166, right? So that just
So that means you did not take your top number and divide it by your bottom number. Because you did not have over 120 ones. So which number is it? Which number did you roll?
no, I said percent.
So you're not going to have a percent that's over 100. What percentage is that? Yeah,
Oh,
18%.
oh, I didn't. I thought you didn't do it.
You go to the hundredths place. Yep. So you should have 6 percentages written down. You have 6 percentages written down? So now I'm going to go through and we're going to do our class count. When I call your name, you're going to tell me how many ones, how many twos, how many threes, how many fours, how many fives, how many sixes. Whew. So this is going to take a little while. You need to be recording as I am. I want to see all the putty away so we are writing. Too many of us have putty in our hands instead of pencils. Connor. Nope, you're going to tell me your numbers. So we're going to add numbers up just like we did with our coin tosses. We added all the heads up and all the tails. This time when we get done, we're going to add up all of our ones, all of our twos, all of our threes. Okay? So, Claire M., how many ones?
15.
Twos.
20.
Threes.
19.
Fours.
35.
Fives.
22.
And sixes.
22.
Bryn.
17. 25. 17. 27. 18. And 16.
Madison.
13. 33. 21. 24. 22. 22.
Callie.
18. 18. 22. 19. 26. And 17.
Melanie.
21, 28, 21, 15, 18, and 17.
Connor.
15, 20, 16, 27, 18, and 20.
Madeline.
12, 25, 11, 15, 36, and 28.
Layla.
19,
21.
19, 22, 19, 24.
What was the last one? Amanda.
20, 23, 21, 21, 15,
20.
20.
Dom,
46, 34, 10, 7, 12, 11,
Sawyer,
18, 20, 25, 21, 20, and 19.
Marina,
20, 30, 15, 22, 25, and 8.
Lauren,
15, 15, 26, 26, 21, and 17.
Cam,
20, 21, 21, 30, 12, 16.
Ava,
23, 17, 22, 22, 16.
what was your last one?
20,
Ruby,
30, 21, 13, 14, 20, and 22.
Zelda,
17, 13, 22, 22, 22, and 20.
Lilia,
24, 23, 15, 21,
I'm sorry, what was after 21?
20, and 17.
Hannah Mae,
19, 22, 22, 17, 20, 20.
and Liv.
25, 20, 30, 30. And what?
10 was the last one?
Yeah.
All right, so here's what we have to do. We have to go across all of our ones and add them up, and we're gonna write that number down by the one. All of the twos. I'm gonna go through and I'm gonna read off the number as I'm adding it in case you missed one of those numbers. So you can follow along with my adding, or you can add on your own, and we're gonna double check which total the majority of us get. So I'm adding 15 plus 17 plus 13 plus 18 plus 21 plus 18 plus 12 plus 15 plus 20 plus 46 plus 18 plus 20 plus 15 plus 20 plus 23 plus 30 plus 17 plus 24 plus 19 plus 25. I got 406. Raise your hand if you got 406. Okay. Some of us are still working on it, but that's okay. I'm going to do the twos now. 20 plus 25 plus 33 plus 18 plus 28 plus 20 plus 25 plus 21 plus 23 plus 34 plus 20 plus 30 plus 15 plus 21 plus 17 plus 21 plus 13 plus 23 plus 22 plus 20. I got 449. How many of us got 449? Okay. Now the threes. 19 plus 17 plus 21 plus 22 plus 21 plus 16 plus 11 plus 19 plus 21 plus 10 plus 25 plus 15 plus 26 plus 21 plus 22 plus 13 plus 22 plus 15 plus 22 plus 30. I got 388. Okay. Raise your hand if you got 388. Okay. So you should be recording these numbers as we're going. You should be adding as we're adding. This is everybody participate, Sawyer. So we have 1, 2, and 3 done so far. Let's work on our 4s. 35 plus 27 plus 24 plus, 24 plus 19 plus 15 plus 27 plus 15 plus 22 plus 21 plus 7 plus 21 plus 22 plus 26 plus 30. After 30 was plus 22 plus 14 plus 22 plus 21 plus 17. Wrong number. 17 plus 30. I got 437.
I got 3.
How many of us got 437? Okay, I think you forgot to put in a number as I read it off. That's why we all do it, so we can take the majority. All right, now our 5s. 22 plus 18 plus 22 plus 26 plus 18 plus 19 plus 36 plus 19 plus 15 plus 12 plus 20 plus 25 plus 21 plus 12 plus 16 plus 20 plus 22 plus 20 plus 20 plus 10. I got 393. How many got 393? Okay, let's do our last one. I have you guys doing it just in case I put something in wrong. So I truly want us double checking everybody's work. All right, for our 6s, 22 plus 16 plus 22 plus 17 plus 17 plus 20 plus 21 plus 24 plus 20 plus 11 plus 19 plus 8 plus 17 plus 16 plus 20 plus 22 plus 20 plus 17 plus 20 plus 10. I got 359.
I got 349.
How many got 359? How many got 349? Okay, I think you just missed a number.
It has to be 327.
Why does it have to be 327?
If you add them, because it's gonna be 4,000. I mean, 2,000.
Why might our total, if we add them all together, might not be correct?
Because there's more people.
No. Because somebody might have counted wrong when they rolled their dice. So it's going to be close, but it might not be 100% accurate because somebody's scores might not have added up to 120. So if we were to add up each person's scores, I'm guessing somebody yesterday I had people catching themselves saying, oh, I rolled 136, so we had to figure out how to take it down to 120. I think we're not 100% accurate in our recordings.
Yeah, because I got 325, so I just erased one and I
Yeah. So, does the experimental probability of the class rolling a die 100 times match the theoretical probability? So what was our total number of rolls? What should it have? Well, let's look and see. 406 plus 449 plus 388 plus 437 plus 393 plus 359. We had 2,432 rolls. So we had a few extra rolls that got counted, so we're gonna use that as our total number of rolls. Instead of 2,000, what was it supposed to be, 2,400?
Yeah.
So we had 32 extra rolls, we're gonna count that so we get the correct probability. So we're gonna divide each of these by 2,432. We're gonna write the percentages underneath, just like we did on top. So 406 divided by 2,432 gives me a 17%. 449 divided by 2,432 gives me an 18%. 388 divided by 2,432 gives me a 16%. 437 divided by 2,432, we got an 18%. 393 divided by 2,432, we got a 16%. 359 divided by 2,432, we got a 15%. So our theoretical probability would be 2,432 divided by 6. So we should have had 405 over 2,432. So theoretically, we should be at 17%. When you look up at your own personal experiment percentages, what kind of percentages did people get? What did you get for the ones?
15, 19, 15.
Okay, so I'm hearing 15, I'm hearing 19. I see here our ones was dead on. We had an 18 and 16, which is going to be closer to that 17% than 15%, right? So what are we noticing about our differences in our experimental probabilities when you do it individually versus adding together as a class? Which one gets closer to the theoretical probability? Yours individually or the class? So if we're looking at these, 18 is just one above, 16 is one below, 18 is one above, 16 is just one below. Which one has the most numbers that were closest to the theoretical probability? Your individual or the class? If you look at all 6 of your numbers. So there's no 135%.
No, I got 130. I just counted all my how many each number.
No, I want you to look at each individual number.
Yeah, I know.
Oh.
Wait, what about like 7?
Oh, yeah. And we knew that it happened with people. But which one is closer? Your personal or the class? Which one is closer to 17%? The class is closer to 17%, right?
But what if you have 17%?
So
I
sometimes
had 17%.
Sometimes individually you can get lucky. We had 5 people that flipped 5 heads and 5 tails. But we had 15 people that did not. Right? Sometimes we get lucky on our own, but overall you get luckier when you're doing it as a class. This comes down to our law of large numbers. So let's look at what our definition for law of large numbers is. Law of large numbers says the more times you do something, this is important to know, it's on the test. The more times you do something, the closer experimental probability gets to theoretical probability. Like I said, there were some people that got lucky, and their probability individually was the same as the theoretical probability. The majority of us, that was not the case. We're not always that lucky to flip 5 heads and 5 tails, right? That's not the normal thing that happens. It's not the typical thing. So the more times we do something, the closer and closer we get to that theoretical probability. We added up 20. So I have people that are busy playing instead of listening. This is on the test that is next week. The more times we do something, the closer to that theoretical probability we will get. After seeing that with the, especially with the dice rolls, does that make sense? Connor?
I'm pretty sure this is it. I know, but are we gonna have to roll the dice or put it down on the test?
We are not actually doing the experiments ourselves on the test. You will be given word problems that explain what happened when the experiment was done. And I'm telling you right now, you're going to need to know that the more times something's done, the closer to the theoretical probability you get. Okay, that was a good question. Let's look at our review. Write the formula or definition. So I should have seen words, stuff written out. The counting principle. Remember, for the counting principle, you have the event outcomes. The event outcome times the event outcome. Oops. So you need to figure out what your events are, and you need to multiply it, each event's outcome together. So if you have 3 events, you're multiplying those 3 outcomes together. Okay, that's the counting principle. A lot of us will forget that on the test. So that will need to be on your help sheet. What the counting principle is. Event outcomes times, event outcomes times, event outcomes. So make sure you're writing down the correct events so that we know how many multiplications we have to do. Probability. Who can tell me what probability is? Oh, the likelihood. So remember, with probability, we need to know what's on top and what's on bottom. So what's the formula for probability? What do we put on top for probability? What do we put on bottom? Zelda.
You put what you want to happen, and on the bottom you put what could happen.
Yeah. I like to call it the desired outcomes, what we want. So what you want, or the desired outcomes, over the total outcomes. How many total possible? Okay. So what you want over the total possible. Compound probability. Compound probability is when we multiply probability of events together. So that compound probability. Okay, the snapping of the putty, it's seriously distracting me. Put it away now, because now you're distracting me with it. It's too loud. Thank you. Compound probability. Multiply probability of events together. So you find each individual event, what its probability is as fractions, multiply the top over multiply the bottom, find the percentage. Theoretical and experimental probability. Theoretical probability is what should happen. So experimental probability is what? What actually happens. Theoretically, this will happen. Experimental is I did the experiment. This is the result that I actually got. Theoretical is what should. You should flip heads and tails 5 and 5. Equal amount of times. What actually happens is, ooh, I flipped 8 heads and 2 tails. I flipped 6 heads and 4 tails. So experimentally doesn't always match up with theoretically. How do we get it closer to matching? Amanda? By doing it a lot more times. So a lot of times in science, when people are doing experiments, they won't just do it one time. They do it multiple times to get closer and closer to that theoretical. Right? So you do multiple trials. Same thing with math. Do it multiple times. The more times you do it, the closer you get to that theoretical probability. Any questions on this page? So we have 8 minutes left. Took a little bit longer than I thought it was going to take. Tomorrow is our Fort Snelling field trip. Friday, before we do retakes, we're going to do a real quick review of this unit. So we'll do that quick on Friday. Monday's Memorial Day. We are not in school. Oh, please stop moving. Listening. Tuesday, I will be at a funeral because we all know that Lucy's dad passed away. So that funeral will be Tuesday. You are going to do the practice test on Tuesday. Wednesday, before we take the test, I will answer any questions people have from the practice test. You'll have the answer key, so you'll be able to see, ooh, I was on, I did it, or ooh, how did Mrs. Gambino get that? I don't understand. So I will answer, oh, please stop moving so we can all hear. I will answer questions on Wednesday, then we'll take the test. If we have to finish it on Thursday, we'll finish it Thursday. Madeline. It is the whole day. Yep, we'll talk about that more in social studies class. So, yes, spring. If you are going to need it for finishing up your ad poster. Remember that, do at the end of class on Friday. Any other questions? So we know Friday we'll do just a real quick review. It's only 4 objectives. So we'll review them quick and do retakes. People can finish up their math packet. Number 12 is due Friday. Remember that Khan Academy is due tomorrow. So I'm going to give us some time right now to do silent work time. Working on Khan, working on math packet, coming and asking me questions if you have any. And if you don't have any math questions, you can start working on your help, your index card, your help card. Shh. If you're watching this at home, I hope you're well and I hope to see you soon. Have a wonderful day.